at with logs is the properties of logs and how you can rewrite them to either condense or expand their properties. So I wrote them all up here for you with the product, quotient, power, and inverse properties to show you how they expand and condense with regular logs and with natural logs. It's the same rules with both of them. But for this right here, you have log base 5 of x times y. And multiplication is product property. So you can rewrite this as the log with the base, whatever the base is, of u plus the log with the base and then the v out to the side. So multiplication logs can be rewritten as addition logs and still give you the same answer. Just don't change their bases. Division logs, that's quotient property, division can be written as subtraction. So we actually looked at these with exponents last semester. So for instance, if I had x squared times x to the 5th, multiplication can be rewritten as addition. In exponents, same thing with logs. Multiplication can be rewritten as addition. If I was dividing, division can be rewritten as subtraction. Same thing with logs. Same thing with powers, everything. The power property and everything. So this division can be rewritten as log base 7 of x minus log base 7 of y. When you have an exponent on your variable, those exponents are actually multiplication. So those can actually just come out front and be rewritten as multiplication. Pretty simple. Roots are just exponents. A square root is an exponent of 1/2. So that exponent can just come out front. So that would be 1/2 natural log of x. If you had a cubed root is just 1/3. If you had a seventh root is just 1/7, etc. So whatever that root is, it's just the fraction version in the exponent. Okay, so we got a little combination of them here. We have a power and we have multiplication. So you can separate them, separate up the multiplication to addition. And again, those exponents can go out front. So it only goes out front for the variable that it's on. Like that 2 does not go out front of y as well. Just the exponent it's on. Just the variable it's on. Again, square roots can be rewritten as exponents. So that's actually x to the 1/2. And then y is already 3. But 3 times 1/2 is just 3/2. And then you can rewrite it. So multiplication is can be rewritten as just addition. Oh, forgot the log. And it's just, again, different ways to solve it to help you with different problems. Sometimes it's easier to have it condensed into one log. Sometimes it's easier to have them separated. So it really just depends on the problem. And we'll see that as we start solving them. And like I said before, your exponents, those can go in front of your logs. They are actually multiplication. Same thing with this exponent. It can go in front. That's 3/2. 3/2 log y. Okay, so again, we got some little division here. With this being a root, this is also 5/2 and y to the 1/2. Just make it a fraction. And fractions, division can be rewritten as subtraction to make it easier for some problems. And remember, those exponents, they just go out front. Now, you don't have to do this in 2 separate steps. You can do this in 1 step if you'd like. That's how I did mine. If you need to do it in 2 separate steps, you can do it in 2 separate steps. It's totally fine. You'll still get the same answer. Okay, if you already have a number out front and you have to take the exponents out front, first of all, that number is out front already, so it goes on both variables. So even when I split it up to addition, that 3 goes on both of them. And then I can multiply the 4 out front to get 12, multiply the 3 out front to get 9. So if you ever have a number out front, it goes on both of them, and then you just multiply your exponents by it. So if you had to reverse it and condense them, remember addition just means multiplication. So this would be log 3x times z. Now this 3 right here is not going to turn into an exponent because it's not in front of your log. The only time it changes to an exponent is when it's in front of the log. So same thing on this one. This 4 is not in front. That is not going to be an exponent. So subtraction can change to division. So this is ln of 4w divided by y. When it's in front of the log, that's when it can go back to the exponent. So this is log, sorry about that. This is log x to the third. Okay, same thing here. When it's in front, it can go back to the exponent. So this is a natural log of x to the 1/4. Fractional exponents are roots, like I was showing you a second ago. So because this is the 4th on the bottom, this is actually the 4th root of x. If that had been like ln of 2/5, what am I writing? Sorry. Ln of x to the 2/5, the bottom number is your root number. So that would be the 5th root, and the top number would stay in the exponent. Okay, this one right here, again, these front numbers can go back to the exponent. And then when it's addition, you're multiplying. So this is log base 9 of x squared y to the 4th. So this one's got multiple. So addition means you're multiplying, and division means you're going to divide it. Subtraction means you're going to divide it. So we've got log base 3 of x. Let me divide that different. That 2 is going back to the exponent, so y squared, because we're multiplying. That 5 is going back to the exponent, but it's minus, so we're going to divide the z to the 5th. On this one right here, both of these are minus, so everything after this minus sign is being divided, everything after this minus sign is being divided. So I've got log base 4 of x, and then I'm dividing the y. I'm going to put that 7 back on the exponent, and I'm also dividing the z, but I'm going to put that 2 back on the exponent. So z on the bottom. Had that been plus right here, change colors. If this had been a plus sign right here, it would have been log base 4. The y was being divided, but the z was being multiplied. So it matters if it's plus or minus. The minus ones go on the bottom, the plus go on the top. Okay, last thing we're going to look at with these today is how to evaluate the logs with the calculator. Because when you put a log in the calculator, like if I put log of 7, it's got an automatic base of 10. Which is like, remember log base 10 of 7? This is saying the 10th power, or the base 10 of the x power is 7. So that's what it's doing when it doesn't have a base there. It's an automatic 10 on the bottom. When it doesn't have a 10 on the bottom, or when it actually gives you a number, your calculator doesn't, some calculators don't do that. So if I tried to do log base 3 of 20, I can't get a 3 at the bottom of that in some calculators. Some do it, some don't. But there is a change of base formula, and it's written up here for your general log, your common log, your natural log. They're all the same. What you're going to do is you're going to take the log of your power out here divided by the log of your base number. So this changes it to a base of 10. You don't see that because it's an understood 10, but it does change it to a base 10. So that gives me log of 20, log of 20 divided by log of 3. Now do make sure you close the parentheses, because if you don't and you put log of 20 divided by log of 3, it's going to give you a different answer. So you do have to close that parenthesis. But it is 2.727. This one right here, we've got log of our power divided by log of our base, and base for the bottom, so make sure you put that on the bottom. So we're going to do log of 81 divided by log of 9, which will give me 2. Okay, this one's got a number out front. Remember, those numbers are just exponents, so that's 8 squared, and this one's 2 to the 5th. Remember, when it's minus, that changes it to division. So this is why we had to know how to condense. Because if you can't do a base 3 in your calculator, you can't solve this in your calculator. You have to take it to a base 10. So that changes it to 8 squared divided by 2 to the 5th. Your base is still 3. So 8 squared divided by 2 to the 5th. 8 squared divided by 2 to the 5th is 2, because that's 64 over 32. So that's log base 3 of 2. And then we can use our change of base formula. So we got log of 2 divided by log of our base. So log 2 divided by log 3. Divided by log 2 divided by log 3 is 0.631. Same thing here, we got a little condensing to do. So I'm going to put my exponent back, and when it says addition, I'm going to multiply it. So log base 8 of 4 to the 3rd times 16. 4 to the 3rd times 16 is 1024. So then I can use my change of base formula. Log of 1024 over log of 8. Log 1024 divided by log of 8 is 10 over 3. Or if you have the decimal, it's 3.333. Okay, so try to practice.